Welcome to Patrick Talks Physics. This video's topic is all about the wonderful world of graphs, which in physics can be just as complicated as anything else. There are many different strategies that can help us to decipher what's going on in the graphs that we look at. So why don't we take a look at a few different types of graphs and see what we could figure out. Our first graph is going to be a displacement time graph. Now every graph that we consider has to have a few key pieces of information, the most important of which is the title, which we have right here, displacement versus time. We also have two axes that must be labeled. Here we have a displacement measured in meters on our vertical axis, and on our horizontal or x-axis we have time measured in seconds. We also have labeled our origin, which is the beginning of the graph. Now all graphs have information drawn on them, and it's this information, these lines, that we need to decipher. Right at the start here, we have a flat line. Now we need to figure out what's going on with this flat line. So for that, we're going to take a look at units. Most important part of this graph that's going to give us all of our information. Now this flat line at the start here represents a plateau. A plateau just means flat section. So at the start of our graph, we're a certain distance away from our origin, let's say 5 meters. And after some time has gone on, we've continued to be 5 meters away. So this plateau is representing no movement. So we're stationary in a displacement time graph when we have a plateau. Now there is some more motion going on here. As you can see, we end up moving towards our origin in that last section. Now we can also add to this graph by adding something below our x-axis. What this just means is that we're moving to the other side of our origin. Instead of being on the right, we've now moved to the left. So just like many things in physics, there could be a positive and a negative aspect to the graphs that you explore. Now, in a previous video I mentioned how important it is to interpret graphs appropriately. Slope and area are going to give us a lot of information. Rather than overcomplicating things, let's take a look at what the slope and the area of a displacement time graph are going to provide us. Starting with a slope, which is calculated as rise over run, let's carefully consider just the units and what they're going to give us. Our rise is represented by the vertical axis, which is displacement measured in meters. Our horizontal axis is time measured in seconds. So if we write this out, our rise gives us a unit of meters and our run is seconds. Well, meters per second sounds pretty familiar, doesn't it? That would be our velocity. So the slope of a displacement time graph gives us our velocity, which we can tell based on just the units. So now let's take a look at the area of a displacement time graph. Now the area will be calculated as base times height, or 1/2 base times height. Depends if we have a rectangular section or a triangular section. But let's focus on this rectangular section here, where my base is measured in seconds and my height is measured in meters. So base times height becomes meters times seconds. Well, this is a little nonsensical. We don't really know what that's going to convert to. So in a displacement versus time graph, it's safe to say that the area is not going to yield important information for us. Well, that was pretty cool. So why don't we see how this impacts another type of graph? Let's take a look at a velocity versus time graph. So we have velocity on our y-axis here and time on the x-axis. The beginning or origin is representing 0 meters per second. Now we speed up in this first section, and then we reach another plateau. Now we start in this plateau at a certain speed, let's say 5 meters per second, and throughout the whole duration we stay at the same speed. So our speed is constant, that's what the plateau represents. And then in this last section, we're slowing back down to 0. Now notice that this graph also dips below the x-axis, which tells us that we're moving in the other direction. In this case, we're speeding up in the opposite direction from before. Now, let's take a look at the slope of a velocity time graph. Rise over run, as always. Let's focus on the units that we have here. Our rise, meters per second. Our run is in seconds. So our rise is going to give us meters per second, and our run is measured in seconds. Well, this is also the same thing as meters per second squared, which is a familiar concept to all of us. That is the same thing as our acceleration. So the slope is our acceleration. Thanks to the wonderful world of units, we're able to figure out what this is going to represent in the velocity time graph. Now let's also consider the other important piece of all these graphs to analyze, which is the area. Now remember, the area is base times height. or 1/2 base times height, depending on whether we're looking at a rectangular or triangular section. Let's focus on this rectangular section right here. Now, the base is represented by time, which is measured in seconds. My height is meters per second, the velocity. If we plug in our units now, you'll see that for the base, we write in seconds, and for the height, we multiply that by meters per second. Of course, seconds are going to cancel out here, which is going to leave us with a final answer in meters. Now, if we stop and think about it, meters is, of course, a measurement of displacement. So, easy enough to say that the area of a velocity time graph is going to give us our displacement. And this is all thanks to units. So in summary, let's take a look at what we've learned here. When it comes to interpreting graphs, a few important pieces of information we need to know. First of which is the slope. And the slope being rise over run, a very handy thing to keep in mind, especially when we look at it in terms of units. Also, the area, base times height. It's all about those units. If you analyze a graph based on the units that are provided on your X and Y axis, you'll be able to figure out a lot of information that you'll need. Well, I hope that was helpful. Share your comments below, subscribe, and stay tuned for more videos to come. Take care.